Okay, guys, here we are. Quarter 2, week 2, day 1. Cassie has a half pound of sugar in her cabinet. Her cake recipe calls for 2/10 of a pound of sugar. How many cakes can she make? All right, well, let's go ahead and find out. If she has a half a pound, that's what we know we can use. Can't use more than that because that's what she has. We're going to divide 2/10 into that. You might already see that you can probably reduce 2/10 to 1/5, but let's just play along and use it the way it is. Okay, we have 1/2, so we're going to keep the first one, multiply it by 10/2. All right, at this point we can see if we can cross-reduce. Is there a way that we can cross-reduce with 1 and 2? No. How about with 2 and 10? Yeah, 2 goes into both 2 and 10. So we're going to cross out the 2, make it a 1. We're going to cross out the 10. 2 goes into 10 5 times. And 1 times 5 is 5. 1 times 2 is 2. Okay, so it's an improper fraction. We can't simplify it anymore because we did a good job here of cross-reducing early. So how many times does 2 go into 5? Well, 2 goes into 5 twice. 2 times 2 is 4. We've used up 4 of the 5, which means we have 1 left over out of 2. So the answer is 2.5. So how many cakes can she make? She can make 2 cakes, basically, or 2.5 if she has the pans and stuff to do that. So the answer is 2.5. Okay, they are asking us to find the quotient, which means I'm going to need a little more room. I'm going to go ahead and scooch it up, and we'll work on it. All right, so can 32 go into 6? Nope. So can 32 go into 67? Yeah, it can go into it twice. 32 times 2 is 64. We're going to write that there, subtract that out. 7 minus 4 is 3. Bring down the 4. That's it. So how many times does 32 go into 34? Well, that would clearly be 1 time. 1 times 32 is 32. Subtract that. We have 2. Bring down the 7. Can 32 go into 27? No, so that would be a 0 here. Okay, so we just have 0 and a 0, so we'd subtract that, and we'd end up with exactly what we had before, 2, 7. And so we have 27. And then we're going to bring down the 3. All right, so how many times do you think 32 would go into 273? Well, I think the answer would be 8. Let's try that. 8 times 2 is 16. 8 times 3 is 24, plus 1 more is 25. All right, so we can't take 6 away from 3, but we can take it away from 13, which means a 7 will become a 6. So 13 minus a 6 equals 7. Okay, and then we have 6 minus 5, which is 1. Okay, and then we're going to have to start adding zeros here. So let's do that. We'll bring down the 0. How many times does 32 go into 170? Well, I'm going to guess 5. So I'm going to kind of rewrite this over here. I wish we had more space. So 170. So 5 times 2 is 10. 5 times 3 is 15, plus 1 more is 16. Okay, if we subtract that, we're just going to end up with 10. Okay, then we have the 0, and we're kind of bringing it down over here now. All right, and then how many times does 32 go into 100? Well, I would say 3 times. It's going to be right around 90-ish, right? Because it's 32 times 3, or 30 times 3. So 3 times 2 is 6. 3 times 3 is 9. To go from 96 to 100, that would be obviously 4. Okay, and we would bring down another 0 and go from there. 32 would go into 41 time. Okay, so we're going to go ahead and stop there. There's the decimal. So I would say the answer, a good answer for this would be 2,108.531. So 2,108.531 would be a good answer for this particular problem. All right, let's find the difference. We are finding the difference, which means we are subtracting. We have decimals, which means we have to line those up. Okay, so we're going to take the 11.8 and bring it over here. 11.8. We'll put a 0 here just for good measure and cross this out. So we're going to just use this side over here. All right, so we have 9 minus 0, which is 9. We can't take 8 away from 3, so we're going to have to borrow from the 5 and make that a 4. So we could put a 1 there. So if we have that, we have 13 minus 8, and 13 minus 8 is 5. Then we have 4 minus 1, which is 3, and 6 minus 1, which is 5. So there's our answer, 53.59. What is the least common multiple of 4 and 16? Well, what are the multiples of 4? Well, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And 4 times 6 is 24. And 4 times 7 is 27. All right, so 28. 4, 8, 12, 16, 20, 24, 28. Yeah. Okay, so then for 16, let's start going and seeing if we can find a number that's the same in both. Let's start off. Well, the first multiple of 16 is 16 times 1, and we can stop right there. Okay, we can do 16 times 2, which is 32. Completely unnecessary because the least common multiple is 16. So that's our answer. Find the missing number of each unit rate. Again, I really don't like the fact that they're calling it unit rate because they're not always ending or have a 1 in the new rate. So let's get rid of that. Find the missing number of each rate. All right, so to get from 7 to 1, you're going down. So you're going to have to divide. You can't multiply to get down unless you're multiplying by a fraction. But 7 to 1, which means you're going to divide by 7. Okay, so if you're dividing the top by 7, you're going to divide the bottom by 7. 21 divided by 7 is 3. So that's the answer for that one. How about from 12 to 2? Well, we have to go from 12 down to 2, which means we're probably not going to multiply. We're probably going to divide. So 12 divided by what will give you 2? Well, it's going to be 12 divided by 6 will give you 2. So 72 divided by 6. What is 72 divided by 6? That is 12. So there's our answer. So for this one, the missing number is 3. For this one here, the missing number is 12. What percent is 24 of 96? Okay, so we're saying 96 is the total amount, and we're talking about 24 of them. So it's not going to be a really high percentage, okay, because it's not going to even be 50%, because it's not, 24 is not half of 96. So let's go ahead and just write it, as a fraction. If we write it as a fraction, it ends up being 24 over 96, or 24 out of 96, which means we're going to have to divide 96 into 24. So we're going to go ahead and work it out this time. So we have 96. We're going to divide it into 24. Well, 96 does not go into 24, so we're going to have to add a 0 to that. So how many times does 96 go into 240? Well, it's going to be about 2 times, right? Because 96 is close to 100. 2 of those would be 200. So 6 times 6 is 12. 9 times 2 is, 6 times 2 is 12. 9 times 2 is 18, plus 1 more is 19. So let's subtract that. Well, we can't subtract from 10, or from 0, so we're going to have to borrow from the 4 and make it a 3. This becomes a 10. 10 minus 2 is 8. Can't take 9 away from 3, so we're going to have to borrow here. So we have 13 minus 9. 13 minus 9 is 4. And then 1 minus 1 is 0. So we're going to add another 0 here, bring it down. How many times does 96 go into 480? Well, it happens to be that it goes into it exactly 5 times. 6 times 5 is 30. 5 times 9 is 45. Plus 3 more is 48. And there's our answer. So basically, it's 0.25. Well, once we have the decimal, 0.25, all we have to do at that time is, or at this point, is multiply it by 100. And anytime you multiply a decimal by 100, you just move the decimal over 2 places. Boom, boom. Okay, so instead of multiplying it all out, we're just going to do that, which makes it that it is 25%. Okay, that's all you have to do to find the percent, is take the bottom number and divide it into the top number. Find what that is as a decimal and change that into a percent. How many centimeters are in 13 meters? How many centimeters are in 13 meters? Well, they show us right here that there is 100 centimeters in every 1 meter. So if we find out what it takes to get from 1 to 13, we'll find out how many centimeters. So 1 times what number will give you 13? We're not going to divide this time, right? So we're going to multiply by 13. Well, if we're going to multiply this side by 13, what are we going to do with the top of it, with the numerator? Multiply by 13. Okay, so 100 times 13, well, you just do 13 times 1, which is 13, and then add the 2 zeros at the end of it. And so that's pretty simple. We know that 13 meters would be the exact same thing as 1,300 centimeters. So that's our answer, 1,300 centimeters. Write the product of, well, all that in exponential form. Okay, well, this is going to be one of the hardest problems you've done all year long. Definitely being sarcastic on that one. It says this is going to be pretty easy. Write the product of that. Well, how many 6s do we have here? Well, we have 1, 2, 3, 4, 5 6s. So it's 6 times 6 times 6, all these. So it's going to be 6. And how many did we count? 5. So that's all you have to do. To write it in exponential form, you just take however many of those there are and put in a little exponent up there. Okay, doesn't need the line. Okay, so it's just the 6 to the 5th power. If these were all 4s, okay, it would just be 4 to the 5th power. Okay, they're not. Okay, so don't write this one down. Okay, so it is 6 to the 5th power. All right, so here's the kind of new concept for this particular week. It says write an expression. Okay, so we're going to be writing an expression, so we're going to be reading words and trying to write an expression that represents that in more of just a normal math equation or expression. So write an expression that represents the sum. Well, when we see the word sum, that means we are doing addition, right? So this is going to be an addition problem. So represent the sum of a number, okay? But it's a number. We don't know what the number is. Anytime that there is an unknown, we usually use a variable. So we'll just go ahead and put the letter A. And they're going to add that number, whatever that is, whatever a number is, we're going to take that and we're going to find the sum of it. Well, since we're doing the sum, it is addition. And then we're going to add 12. All right, that's it. So whatever A is, if A is 1, it's going to be 1 plus 12. If A is 7, it's going to be 7 plus 12. But we don't know what it is, so we're writing an expression, so we have that, that represents the sum, there's our addition, of a number, which is this one, and 12, which is this one. So our answer is A plus 12.